Good afternoon, students. I hope you're all doing well. So today's learning objective is I can represent numbers using exponents. Let's go over today's agenda. So I'm going to introduce some properties of exponents. We're going to learn what an exponent is in mathematics. We'll go over the vocabulary, which includes power, exponent, and base. We're going to do some practice in our slides in our introduction to exponents. The lesson is how to write numbers using exponents and evaluate them. And we'll do some independent practice, how to evaluate powers and express whole numbers as powers. And then the closure is we learned how to evaluate powers and express whole numbers as powers. So the learning objective that we're going to focus on today is I can represent numbers using exponents. Let's get started. Let's talk about what a power is. Has anybody heard the word power? It's not like power, oh, we're strong, we're powerful. This does have power in math, though. A power is another name for an exponent. So it is the result of a repeated multiplication of the same factor. For example, if I have the number 3 to the power of 2, 2 here is my exponent, it's my power. And I can actually read this term as 3 to the power of 2, or 3 squared. Now that 3 is actually a base. So in math here, the base is the number or variable that is used as a factor in repeated multiplication. And then once again, exponent is the power. It's the number that represents the number of times the base is used for a factor. So the exponent, the power, tells us how many times to use the base as a factor. So here, my big number, my base number is 2. My power, or my exponent, is 4. So this is very important because we can read this as 2 to the power of 4, or the 4th power of 2, or even 2 to the 4th power. So what this means is I have 2 multiplied by itself a total of 4 times. So I will show you here. I have 2 because that's my base, and I'm going to do my dot. Remember, that means multiplication. We're not using X here because it becomes a little bit confusing. Times 2. Am I done yet? No, I'm not. Here, my third 2. And then my 4th 2. Can anybody tell me what 2 to the 4th power is? Or 2 times 2 times 2 times 2 is? You got it. 16. Awesome. Now, how do we evaluate powers? Let's try this example. So I've got 4 to the 4th power. Now I showed you 2 to the 4th power. Now let's try 4 to the 4th power, or 4 to the power of 4, right? So 4 to the 4th power is 4 times 4 times 4 times 4. It's 4 multiplied by itself 4 times. So you're using 4 as a factor 4 times. and 4 to the 4th power equals 256. Let's do another example. Ooh, 2 to the 5th power. So we're using 2 as a factor 5 times. So I have 2 to the power of 5, or I can also say 2 to the 5th power. I have 2 times 2 times 2 times 2 times another 2. And what is 2 to the 5th power? It equals 32. Let's try some with your partner. Okay. Try this. Find each value. We have 3 to the 3rd power. You can also read that as 3 cubed, or 3 to the power of 3. And then you're going to try 8 to the power of 2. You could also say this as 8 to the 2nd power, or 8 squared. Has anybody heard 8 squared before? Yeah, we use that a lot when we find the area of something, and we'll get into that later. So go ahead and try to evaluate 3 to the 3rd power and 8 squared. All right, let's review. So for 3 to the 3rd power, we're going to write 3 times 3 times 3. And that equals, you got it, 27. And then for 8 squared, or 8 to the power of 2, you should have gotten 8 times 8. And what's 8 times 8, everybody? Awesome. 64. Very good. Okay. Let's move on. Now, a couple of things we have to remember, what you should know. Any number to the 1st power is equal to that number. So if you have a base and the exponent is 1, the answer is always the base. So 6 to the power of 1 is 6. 14 to the power of 1 is 14. 25 to the power of 1 is 25. 1,000,000 to the power of 1 is, 1,000,000. Now, any number to the 0 power except 0 is equal to 1. And I say except 0 because 0 to the 0 power is undefined. It's not possible, okay? It doesn't equal 1. But here we have 6 to the 0 power equal 1. 14 to the 0 power equal 1. And 25 to the 0 power equal 1. And this is what I mentioned earlier. 0 to the 0 power is undefined, meaning that it just doesn't exist. Okay, so tell me again, what's 2,000,000 to the power of 1? Yes, 2,000,000. What is 3,000,000 to the power of 0? Yep, it is just 1. Good. Now, to express a whole number as a power, we write the number as a product. What is product? Yes, the answer to a multiplication sentence. We write the number as a product of equal factors. Then we write the product using the base and an exponent. So here we're kind of working backwards than what we just did, okay? So we're given the number 1,000. And you have to ask yourself, how can I write this with a base and an exponent? So we're trying to figure that out. I'm going to use base 10 here. So I have 10 times 10 times 10, which is 10 cubed, or 10 to the power of 3, or 10 to the 3rd power. So first we express the whole number as a power, and then we're writing the number as a product, they're all being multiplied, of equal factors. All the 10s are equal, right? So then we write the product using the base and our exponent here. Now, we're still going to practice expressing whole numbers as power. So here I have 625, and I'm telling you that the base is 5. So if I'm giving you that the base is 5 and we need to end up with 625, we need to figure out how 5 is going to be used as a factor to get to 625. So 5 is used as a factor 4 times. So we have to write 5 times 5 times 5 times 5. How many 5s do I have here? I've got 4 5s. So my base is 5, right? It's my big number, my base. And then my exponent or my power is 5 to the power of 4. So 4 is my exponent, it's my power. Let's try another one. Write each number using an exponent and the given base. Okay, so I've got 81 and base 2. I already noticed an error here. This should be base 9, right? Can I have 2 as a base? No, I can't. I can't have 2 as a base here, but I can have 2 as an exponent, right? Because I know 81, I'm automatically thinking 3s and 9s. They're all the factors of 81. And if I have base 9, 81 is equal to 9 times 9. So 9 here is used as a factor 2 times. So our answer then, using an exponent, is 9 squared, or 9 to the power of 2. Okay, I want you to try this. Try 243 base 3. Okay, so if my base is 3, I'm going to write 3 here, and then my multiplication symbol and do 3. Is 3 times 3 243? No, it's not. Keep going. Is this 243? Nope. Is 3 times 3 times 3 times 3 243? Nope. Keep going. Here's another one. Here it is. 3 times 3 times 3 times 3 times 3. What is that, everybody? 3 to the 5th power. So 3 is my base, 5 is my exponent. So 3 is used as a factor 5 times. My answer is 3 to the 5th power. Let's keep going. Let's try another problem. All right, I've got 16 base 2. All right, let's see here. Go ahead and try this with your partner. Oh, you kids did this so quickly. Wow. Good. So you have 2 times 2. Am I done? Nope. Am I done? No. And what does that equal? 2 to the power of 4. Awesome. Good job. All righty. Let's do an application problem. Let's see how this is used in real life. I already talked about how we apply exponents when we're solving for the area of something, like if you're getting your floor done or needing to find the area of something. So in a game, Enrique had a starting score of 1 point. He doubled his score every turn for 4 turns. Write his score after 4 turns as a power, then find his score. This seems a little challenging. Let's think about it. So he had a starting score of 1 point. Then he doubled his score every turn for 4 turns. How would we do this? So the first turn he had 1 point, right? But after the first turn, he had 2 points. After the second turn, if it doubled, he had 4 points, right? After his third turn, he would have had 8 points. And then after each turn, Enrique's point total is 2 times greater. So with each turn, we have 2 times 2 times 2 times 2. We can turn this into an expression of exponents by having 2 to the power of 4 or 2 to the 4th power, which is 16 points. Yeah, cool, huh? Okay, here is your exit ticket. I would like for you to work on this individually. For numbers 1 and 2, you're going to find each value. Okay, you're going to show me how you write a repeated multiplication sentence and then solve. And then for 3 and 4, you're going to write each number using an exponent and the given base. All right, when you are done, please let me know and we will go over this. Fantastic job, kids.